Right, let's have a look at the third question, number 3. Given that the quadratic equation 2x squared plus 3k minus 1x plus brackets 3k squared minus 1 equals 0 has two distinct real roots, show that this inequality holds. 5k squared plus 2k minus 3 is less than 0. And find the range of values of k satisfying this inequality. Okay then, so I've written down the equation. This is a quadratic in x and it has two real distinct roots. So for that to be the case, b squared must be greater than, not equal to, because that would be equal roots then. So here, b squared is greater than 4ac. That's what will give us two real roots, won't it? And so, let's have a go then. B squared. I'll just circle the a, b, and c so we're absolutely clear. There's a. The number of x's is the b. Oh, great. The number of x's is the b. There we are. And that one is c there. The third value is c. So we've got b squared is greater than 4ac. So b squared then is 3k minus 1 squared is greater than 4 lots of a, which is 2, lots of c, which is this bracketed term 3k squared minus 1. So what have we got then? We want to end up with this. Well, let's just expand the bracket. This bracket expands to 3k squared. No. Let me just get rid of it because it's not 3k squared, is it? It's 3k times 3k, which is 9k squared. The middle two terms will add up to minus 6k, won't they? Plus 1. Greater than 8 lots of, so there's an 8 here, times 3 is 24k squared. And then 8 times minus 1 is minus 8. So that implies then. So move this 9 to be over here. So I'm going to write it down from right to left. 24 take 9 is 15. And then move the minus 6k over. Becomes plus 6k. And then move the 1 over to minus 1. To be with the minus 8 makes minus 9. And I've moved everything over to the right hand side. So it will be less than. So I'm moving it from right to left. So this is less than. And there's nothing left here. So we can put 0. There's a 3 common all the way through. So divide by 3. And then we get divide by 3 here. Which will be 5k squared. Plus 2k. Minus 3 is less than 0, which is what we wanted up here. So that's the first part then. Now we need to factorize it, don't we? We know it's a quadratic in k, so we can do a little sketch of it. We know it's going to be a U-shaped curve. And so we can draw a quadratic to represent this quadratic in k on the k-axis, and this is the value of k up here. So let's factorize it then. The 5k is nice because it's just 5k. It has to be 5k and k. And the 3 is also nice. That's got to be a 3 and a 1. And the only way around I would think it could go is that way, isn't it? This is a plus. No, that's not the right way around. It's the other way around, isn't it? Sorry. That would be a 1 and that would be a 3. There we go. And it's a plus, so that's a plus and that's a minus. So here we've got roots. So we've got this quadratic. It's a U-shaped curve. It has roots at minus 1. Because that equals 0 when it's minus 1. And here k will be, well, let's just write it down. K plus 1 equals 0. K equals minus 1. And we've got 5k minus 3 equals 0. 5k equals 3. And that would imply k equals 3/5. So we've shown our workings there for the value of 3/5 to come out, which is here. Okay, so this is less than 0. It's a U-shaped curve, so we can sketch it in, so to speak, like so. So here we see that for this value, this values of this curve is the y values, to be less than 0, it must be under here, mustn't it? So it can go up to but not touch 3/5. And not touch, so it's less than, and it can go down to but not touch minus 1. There we go, there's the inequality then for question 3. Great.